Awesome. So, so I think we're going to recap. Me and kind of Jerry went through a little bit of this last time, but I feel like these are getting used more often. Every time I hear RAG evals or evaluating RAG, I'm seeing more of these techniques and approaches. So there's a little bit of the basics I think we do, and we'll probably go through some more complicated stuff. If you think about retrieval, there's like a query and a set of chunks returned. And what we've been doing is, and I think Jerry's been doing this as well. I've been seeing, is basically looking at on a chunk by chunk basis, was the retrieval, good or bad? Does it answer the question that the chunk, does the chunk even have a chance of answering the question? And you can imagine if you get all no's, all zeros, and you don't have any context to answer the question, you're very likely to not answer correctly. I mean, you're even more likely to hallucinate. I don't know if you've seen that, Jerry, like feeding in almost all irrelevant data, if you're more likely to just generate garbage.
Yeah, definitely. I mean, we have, I guess we don't have rigorous benchmarks of this, but we've definitely tried this. If you load in, like, set your top K to very big, and basically, it's the whole loss in the middle problem. You retrieve a ton of context and the stuff is in the middle, it tends to actually forget about it. And so a lot of times, like, it's like the finding the needle in the haystack. If you just insert it in the middle, a lot of LLMs don't actually find it, or find that information.
Yep. And I think when you look at kind of it on the right here, you've got kind of an ordered list of what is kind of relevant and maybe what isn't. And you can think of this as a more of a traditional search and retrieval problem. As soon as you get this type of data, like, did I retrieve anything correctly? Did I, is the first thing correct? And I think we've been using kind of precision at K, MRR. I've seen, Jerry, a couple of your reports also use MRR. And so you also thinking of this as like a traditional search and retrieval problem yourself?
Yeah, it's like a ranking problem. So basically, you get back a set of retrieved chunks, and so the chunk at the top typically means that this has the highest relevance, and out of the top K, like the one at the bottom, is the one with the lowest relevance, and then everything else obviously isn't retrieved. So a lot of these are metrics that kind of weight whether or not the ground truth is both one retrieved and two at the top of the retrieved list. So this is like a standard information retrieval metric. I think in the next few slides, maybe just a prediction of what's ahead. Like, I think you have a few examples of actually using LLMs to determine relevance, as opposed to purely using like the ranking metric, right?
Yep.
As ground truth. And then the other piece that is interesting, by the way, is I think we should evaluate retrieval on its own and the quality. But there's an interesting interplay based on what we just said between kind of the ranking plus how the LLM actually perceives that ranking. So a lot of times, if the stuff is in the middle of the context window, the LLM might actually forget it. And so how do you actually think about ordering the retrieve set in a way that the LLM can actually attend to it well? That is something that's pretty interesting, right? I think, by the way, Claude like 2.1 just came out, I think, an hour ago, and
So
I think there was some graph that basically showed that, like, Claude 2 attends to things better when it's at the bottom. And
wow.
so then, if you're using Claude 2, does that mean you want to basically flip the entire order of your retrieved set, right? Put the most important stuff at the bottom just to make sure it can actually read it? That part is an interesting question, right? And so this is
Yeah.
just an example. But either way, like, I think we should think about retrieval evals.
Yep. And then I guess a question for you. So what we typically do is we have been using, like, this is kind of an example of a template that's used for an LLM evaluation of this chunk. Do you do these LLM evaluations, or do you use like cosine scores for yours typically? Like, what do you use to build this on your side? And I'll say on ours we use LLM evals for relevancy.
Oh, so the way we actually do it is so this is interesting. I think the way we typically construct a data set for retrieval
Yeah.
is we do it synthetically using GPT-4. And
Yeah.
so if you take in a document and you break it into a bunch of chunks.
Mhm.
So for instance, I think that's like where you see the begin like data tag over there.
Yeah.
You take each chunk of the doc and then prompt an LLM like
Yep.
GPT-4, Claude, to generate questions from that chunk. Now you have like the question and context pairs, right? You have the question as the input and the context as like the output ID. So then you can actually run like just, given that you have the ground truth, like ranking metrics against it. Of course, if you don't have the ground truth, then you can use the LLM as a proxy, right? Just basically kind of what you're saying. Use the LLM to determine how relevant the chunk is to the question.
Yep. Cool. Well, we'll keep going. We'll go. So there's kind of a couple different ways to do this. And in this example, it's kind of the LLMs evaluating each chunk and giving you a ranking set here. You can pre-generate the questions that kind of do this. And then there's kind of like the higher level thing that we've been using too to evaluate like overall, did the system answer correctly? And it's really called a question and answer eval. Like really trying to get at, given the question, given the context, so all the chunks returned, and given the answer, is the answer likely correct? And we've been testing these, and you'll see both of these results against human labels. Both these evals, like how well do these evals do when you really have ground truth? And you'll see the results on different model sets in a bit. But this one, I think what I've found is just, GPT-4 and some of these larger models they're much better at grading themselves, maybe as a judge, than maybe even generating the answer in the first place. So like people sometimes get hung up, am I using GPT-4 to grade GPT-4? But it actually does a decent job. And what you're asking it to do is not evaluate a question answer on public data like Michael Jordan, what's his age. It's answer like here's the context. Here's this private information I have from my docs or from internal context. And here's the question, here's the answer, and it has everything here to kind of make its own decision if this question was answered correctly given this data. So it's a very kind of succinct problem versus like public question and answer type things where did it memorize Michael Jordan's birthday? And this is important for overall system. So these two, retrieval evals and question answer evals, are something we actually recommend like everyone run over there, like when they're first starting, and it's just something to be able to gauge your system performance. You don't need to run it every time. It could be samples, but you should be running this. It's kind of our take. And what does it look like in practice? Well, something maybe like this, where you've got two chunks of data returned, you've got a relevance for each one, you've got a Q&A on the total response. And normally what you'll see, we see this every day, is like if both things are irrelevant, you're kind of off on the question side. Like you're getting off in the weeds and not answering it correctly. And so that you can think of the relevance as kind of helping you pinpoint where in your system, how well is your retrieval doing in your system? And then the last one is kind of how well is, the customer's experience relative to that question answer. Anything else to add on this one, Jerry?
No, this looks great.
Cool. This is a new one we've been doing, that can be helpful to ground the thing. So if you look at this one, your question might be, well, is my Q&A eval correct? Like, I'm using this to try to gauge correctness in the system. And again, we have kind of two modes of these. One is just let it be the proxy for performance. And this is kind of helpful because we find like people are adding human labels, or they have human labels. Like, here's a set of questions, here's my good answer. And really it's about trying to understand whether the answer from the AI matches that label. Like just how well is the system, answering and matching what a human would have answered relative to that question. And it's just another good proxy. It's really, a lot of people don't have human labels. It's hard to get human labels, but when you do, and you're starting your system and starting to build it, it's just a good way to, like, if you can get this, and like, for example, in our case, we had our team label like 200 answers, stick it in a knowledge base. And it gives you some really good gut checks on how well it's answering relative to what perfect is. And it can help if like you're doing QA, you just gut checks your QA. Like is my QA eval correct? And it gives you a good idea. It's like a one more level of check on the LLM evals you're applying. The other one we've seen come up as well is a reference link eval. So a lot of question and answer docs have a link to the docs as a something that it returns. Okay, so there's a and what that does is, what teams really want to do is, like, in addition, is the QA working correctly? Is my link correct? Did my link actually contain an answer that was helpful to the person? And this one we've been seeing out there and using has been like, takes actually the full conversation. So there might be a lot of back and forth with that combo going on that finally gets to a link or two. Sometimes it's more than one. And so we typically take the full conversation in. We pull down the page. So we use LlamaIndex to pull down the page, and then run the eval kind of runs looking at the text of the page, the conversation, and just like, did it answer correctly? So this is another common thing in there, and we have some examples in the Phoenix evals has some examples of this. This eval is in there and tested. I would say also showing up in a lot of customer base. And there was a question here. Let's see. Is there a way to know how many human questions are enough? It's a good question. No pun intended. How many questions are enough? I think it's a hard answer. I mean, I think it's going to vary. I mean, this is kind of a non-answer, but I think it's going to vary. I think what's enough is going to be normally what I'm trying to feel when we're building this stuff is we run things enough times, we add more answers, and you don't get a lot of variability. Just meaning like you run to run, or say you add another 100 answers to the question sets, and your Q&A rate doesn't drop. And like it's more about like variability and being in the raw data and feeling good about wherever the variability is, that you've covered enough, that things feel stable enough that like you have a good gauge of how well it's going to work. That's probably my best answer for that.
You can also just do I guess like a little bit of statistics. Like, you have a sample set, like 50 data points. You measure the mean, you do the sample like standard deviation, and then you basically can draw a confidence bound around like the rough, like 95% probability that the evals, or that the answers will fall like kind of within this range. Obviously, the higher the sample size, like the lower the standard deviation, the width of the confidence interval.
Yep. Yeah, I think good question. Good question though. There was a couple of questions here. So let me answer some more. So NER keyword extraction. So these are just some statements that we're saying. So the NER keyword extraction models, fuzzy matching, another good way to gut check LM evals at scale and find edge cases of what skips through. Also helps pretty often for domain specific applications where embeddings. Agree. Agree. And we'll get some other ways of gut checking the evaluation here. But just example of like what this looks like in practice. You have a reference link, you have like a query and a response, and the question, and it's not even like a query and response. It's more actually a conversation typically that we collect. But then you're looking at this page, and is it the right page to send the people to? Does it contain the answer? So this is kind of I would say the suite of evals that I'm seeing across a lot of production RAG systems. One other thing we've added recently to the Phoenix library, and it's just again another way of getting a gut check. This has been immensely helpful. Highly recommend in the beginning when you're doing this to do this. We now have an explanation flag, so you can get an explanation for why the eval occurred, and for relevance, it will tell you like where why it made its decision, and it helps you understand, like, is this really off? Is it off in the weeds? Is it does it actually work? And under the hood, that we've done this with functions with GPT, OpenAI. I think we've also added a version of this that works without functions too. So models with it that aren't OpenAI, this also is available with. But like highly recommend as you're gut checking your evals, LLM evals, that is, you add explanation fields to help you explain why it's made the decision it's made. And in this case, a relevancy explanation is trying to see a question and see if this chunk contains an answer to the question. And the relevant means it is relevant to that question. And the explanation is kind of telling you where it got its answer in the paragraph. Question. Yeah, and so one question we have is, if you run evals in CI, how do you mitigate the probabilistic nature of it so it doesn't break the pipe so often? Any take on that one?
That's a good question.
I don't find it as like temperatures. I mean, part of it, temperature zero. I don't find it as, things don't flip that much. Like I think at least with the evals that we run, it's not as big a flip or probabilistic as you think. Now it depends on the model. Like I've actually seen some models where you put the thing. There's some models in the set here where you put the model, you put the explanation in twice, you'll get different answers. But with the larger models like a GPT-4, I don't see as much variance as you might expect on the same data sets. I don't know. Any thoughts on?
No, yeah, I think I agree with what you're saying. I'm just trying to think. Like, I don't think there's I personally haven't seen a ton of examples of doing evals and like CI. I think there's like a variety of complexities. I think there's like, yeah, there's the probabilistic nature, but there's also just costs. Like, I don't know how often you're like pushing to GitHub or what model you're using, but I think that tends to be like a limiting factor too. Because like if you're doing this in the automated fashion, you're going to run up against your credit limit like pretty quickly. But yeah, it's definitely a challenge. I think I've talked to a few eval companies that are basically trying to plug into like your CI workflow, right?
Yeah.
So I'm interested in seeing how that evolves.
Yeah, I think it's gonna, it will happen for sure. Like it's the checks are good enough, the gut checks are good enough. Yeah, the note someone dropped in is of using the seed is actually a really good idea. So the seed is obviously a new addition to OpenAI, where you can kind of expect to get I think the same results with the same run. So that's an idea too. I would just venture guess with Phoenix with our default settings. I don't see as much variance as you might expect. And we'll talk a little bit about the different models. From an evals perspective, this is our scores. So this is like our runs. There's test data sets that we run it against. Your data might vary, so don't take these results as total gospel. But I do think the relevance evals, retrieval evals that I was talking with Jerry ahead of this, like I've seen it struggle. Like it's hard. There's something about retrieval, understanding the context and understanding the question and understanding if you can answer it. There's something about it that seems hard for the smaller models. And so like, right now we recommend customers, GPT-4 Turbo is probably the recommended for the full suite of evals, given results we see ourselves. Again, your data might vary. I do think some of these Claude is, an awesome LLM. It just test on your data and build a data set and build your confidence on it. So one other thing we kind of wanted to know was do functions and explanations affect the final result? Because we're kind of doing them at the same time. And there's almost this concept as well. We don't have anything in here on this, but we've been seeing this concept of what I would call like multi-output evals, where you're asking the LLM to do multiple things at once. And people have been doing it to try to stuff more, like it's more like cost and time. Let me have it generate 3 things instead of 1. And so one of the questions was like, if you generate an explanation, does it help or hurt it? Like it's doing both the categorical relevance or not relevance, and it's generating an explanation. Does it actually hurt performance? does it help performance? And then does function calling, like I do an eval with function calling, I do it without function calling, does it actually hurt or help performance? And I think we were kind of surprised that it doesn't look like it does much. Like it doesn't look like it affects much. So right here you've got like an accuracy in F1 without function calling, so no functions. You got, with explanation, so this will be with functions in this example. And this is just function calling alone. So you can see, I mean, there's a little, maybe a little dip with just function calling alone, but like really not as big of a leap as I would have thought in these here. And so same ideas down here. You've got you've got kind of a eval suite with different ways in which we might be trying to get that eval out, and having the model do multiple things at once. And I do think, like, I mean, yeah, I mean, with explanation, the variation looks very, small enough that I probably wouldn't, I probably wouldn't worry about, I think the short of it is choose which one you want to do and whichever is easiest for you. And it doesn't look like it affects the actual results. And these are, again, against human labeled test sets. I have a couple examples here of just, again, how do you use this overall? Well, there's some benchmarking stuff that we've been doing there's an awesome benchmarking script with LlamaIndex that sweeps through Q&As and different chunk sizes. And again, you can use these evals. So the red number here, this means like 5% incorrect. So low number is better, 2% incorrect across the data set. This means 23% incorrect. Something's really going on here. So you can get an idea, though, like different chunk sizes. Again, there's a too small, that's not great. There's a too big, that's not great. There's kind of like somewhere in the middle. Again, data sets vary, but this is just an example of like why you might use, like how you might use evals for understanding your system as you're setting it up. I'm also interested in Juan's question. Is there Q&A? Does more, so it's Christos put it in, does having more LLM eval at each step, retrieval QA, human error, riffling, pitch info, increase or reduce the probability of error? Not sure if 95% probability is series or parallel. I think each one I think each one of these kind of helps you understand different failure points in the system. Is kind of my take. That I kind of feel like the more I kind of feel like I would think it helps reduce, if you're running more in parallel, you just have more visibility into where things might be off or wrong. So I think it's, I've found that it's good to run some set of these, and again, it doesn't need to be on every data point, every eval, but some sample set that helps you troubleshoot is pretty helpful. Keep going here. So we do, I'll kind of hop through, and these are just go quick here before we hop into some of the multimodal stuff Jerry has. But yeah, so the MRR, just wanted to note that as you're measuring MRR, it's hard to see here, but this is a little, this is higher than these here. So the chunk 500 is higher than the 100, which is, again, you would think, and this is just saying that we're more likely to be retrieving something that's useful in the set that's retrieved. Go figure. That kind of gets you your answers there. But then you saw the Q&A was kind of failing at 1,000. So even though this retrieval is even higher here at the higher chunk sizes, it still doesn't mean I'm going to answer my question correctly. So this gives you an idea of how well your retrieval is, but not necessarily, doesn't actually tell you the big picture that Q&A tells you either. So cool. Keep going.
Oh, yeah, I guess we don't have too much time. So I'm this, by the way, this is just like experimental in terms of thinking about like a multimodal world. Before that, I just want to quickly answer, there was like a question on, should you, I think he asked how much attention should you spend evaluating individual components versus more end-to-end eval? And maybe just double click into that. It's a good question. I think, to be honest, I think we don't actually have a concrete answer. I think what we've have done, I think it's flipped. We used to think like, do the individual components first and then do end to end. But in reality, end to end is just a lot faster because you just take your question, look at the generated response, and then kind of, just run some end to end evals, validate, sanity check whether or not it's actually working. And then if it is broken, then you can go in and try to diagnose whether you do need to evaluate retrieval, right? So because evaluating retrieval in isolation means you have to set up like a separate data set, you have to go in and actually measure like separate metrics. So just that's my current take. Currently for multimodal evals, this is just like a fun experimental section that we're adding right now. The reason why are we doing this? The reason is we anticipate multimodal is going to become a bigger part of people's lives. Like there's a lot of more multimodal models coming out, and from GPT-4V to Lava to all the variants like 1.5, Lava Video, and there's a lot of people exploring use cases in document processing, image understanding, image retrieval, those things. Here's just a basic diagram. It's kind of like a spot the difference game where they look actually pretty similar. But if you take a look at the right, the way multimodal like RAG system works is that instead of just like indexing both text, you also index both images and text, right? And jointly. You could put it in the same vector database collection, like Chroma now supports this, or you could put it in like separate vector database collections. I think the high level idea is that if you're setting up something that's like multimodal RAG system, like you want to query both images and text, the evals actually end up being pretty similar. Just take all the concepts that Jason was describing, for retrieval and apply it to the image setting as well as a multimodal setting. So if you go to the next slide really quick. Yeah, this is just like describing kind of what text-only RAG versus multimodal RAG is. And basically, the main difference with multimodal RAG is you're using a multimodal model and you want to index both text and image data. And then if we go to the right, and we'll probably just see if we can end there. Oh, next one. Yeah.
Okay. Yeah.
One after. Sweet. High level idea. If you separate out the image and text modalities and you index both images and text, you can compute retrieval metrics similar to what we just described on both images and text. And if you want to evaluate the quality, like relevance of a retrieved image corresponding to the query, similar to how you evaluate the quality of retrieved text corresponding to the query, use a multimodal model, right, instead of like a regular model. And so that's basically it. I mean, I think there's links to this full notebook that we have in like the next few slides. I'm sure we could probably share this out as well. And then of course, like, we integrate with Arize Phoenix. So basically with one line, you can pipe all these like traces, observability, and eventually like evals down to Phoenix.
Yeah, definitely check out the one-click integration. It's pretty awesome. Any other questions? Can we get the PowerPoint? Yes, we will. How about we drop it? We'll drop it in the community. There was one other question, a couple other questions here. So have you compared the results when smaller chunk sizes are given a higher K value versus a larger chunk size at smaller K? There is some so some of the benchmarks we did have here do have some of that. I think so. So there's like K equals 10 at 100 versus over here, the chunk size being 500 K4-6. I would say there's just something about as K gets to 10, things, I wouldn't say it always get worse. I guess they got a little better here for the 100. Probably, as you look at it, I just find, I mean, my little gut check is it's much more consistent, K equals 4 or 6, 3, chunk size 300, 500, and at least on this data set. Again, your data set may vary, does seem to outperform the pure, K equals 10, 100 type thing. Benchmarking scripts that we have allow you to do these sweeps. You could, you could set K equals 20 or whatever sets you want and do the tests on your own data too. What else? Was there any other? There was one more question here. Has anyone made an agent we can hire to perform RAG evals for us? We're working on that one. Jerry, you got anything cooking there?
An agent to
I think it was a little bit of a joke, a little
Okay.
bit of you know, I don't think we're quite there yet. Any work on the agent space that you've been doing?
Um, well, yeah, well, I mean, we just launched like a RAGs thing today. Like you use natural language, an agent to basically construct a RAG pipeline. So yeah, you could feasibly have an agent construct evals. That's actually not a bad idea. It'd be like a fun hackathon project if you guys are interested.
Yeah, totally. AI to evaluate AI. I mean, that's essentially what LLM evals are. So, um,
Yeah.
great. Okay, so there's a couple more questions you haven't already answered. Join us. Okay, what do you track? What are you using to track your metrics? Langsmith weights and biases, ML flow. I mean, currently, I mean, I'll say I'm gonna get a plug for us. So Arize has kind of two offerings, and what I would say Phoenix probably competes. Langsmith is kind of sitting in between. It's both development and production, where our Phoenix solution you're going to find is probably focused more on development, experiments, iteration close to code. So Phoenix is kind of what we have been pushing teams for. You'll see more and more around it. It's open source. Langsmith is not. Cloud, Arize Cloud has, it's probably the leader in production, hands down. And yeah, a lot of top teams in the world use the cloud solution. Weights and biases. I mean, again, and then I don't want to, feel free to compare it to all the solutions out there. I think we got to win on product, but check it out for sure. ML Flow 2. I mean, I don't know. Like I would also venture a note that I don't think there's really, like, I think the market's still really open. I don't think there's any clear winners and great products. So we're all building. We're all trying to build something amazing that takes the market. But try them all out. Try Phoenix. Optimal. Anything else to add, Jerry? The optimal chunk size depending on information. Last question.
No, that yeah, you should tune that.
Yep.
Yeah,
Yeah.
that's the best answer I can give.
Yeah, and some Phoenix. A couple last notes. Just I'll plug our open source stuff. I mean, we're putting a lot into it. I personally love what the team's doing there and contributing to that. We do now have a server version. I think we launched last week, which it can run on its own. It was originally, so it can run in your notebook, it can run on its own. So a self-hosted version of Phoenix was just launched. Expect a lot more coming around persistence, and a lot more coming. And again, we're dedicated to this open source side of things and trying to build some amazing development tools for the community. So expect more coming. Awesome. Well, thank you
Cool.
everyone for joining, and yeah, anything
Thank you,
else?
Jason.
Yeah. Thank you, Jerry.
Thank you all.
Bye.